For our final scenario then, is getting two isolated Docker container to communicate directly with each other. In this case, I'll be sending the Gazebo video feed from the RG pilot container into the object detection container, where it'll be processed using a pre-trained model. At the same time, I'll still be connecting to Mission Planner on Windows to plan and run an autonomous flight mission. The video feed won't be going to Mission Planner this time though, as it's being consumed by the object detection container instead. Sending data to multiple destinations simultaneously is possible, but that's something I haven't explored yet, so I'll leave that for another time. First things first then is, how do we get the two isolated containers talking to each other? Well, the key is a shared Docker network. Let me walk you through this, the relevant part of the Docker Compose file then, more case of this section here. So, in this case, you already know we're needing a network to share between these two Docker containers. So this here, for the first one then, simulation net, and this is just a nickname for this current Docker container that we're using. It's just a nickname for it to share, or just a name for it, and that's fine. In terms of the second one, which is external true, what this does is that it'll tell the Docker to not create a new network when this compose file runs, because we already created it manually, and to do that, all you would have to do is run the following command, just show briefly then, and then I'll explain the name, because you need this. So it would be just like docker network create, and then you would just run the name they both shared. For my case, it's shared network for robotics. If I were to run this, it says there'll be error out because I already made one, so that's fine. For your case, you haven't yet, but that's it. Okay, and for the final tag then is name. So this name is very important, as this field needs to be matched exactly across every Docker Compose file. For any container you want to have it share its network. Alright, a good way to think of it is the name is an island, and the nicknames are the people living on that island. Different people, same island. Okay, these are nicknames, different people, and then this is the island's name. Same name. They have to share exactly the same. So let me show you the other Docker container then, running my object detection then. So different nicknames, okay, and then the same name for the network, right? Network name, and then nickname for this certain container. Okay, now we've got this out the way. There is another thing we do need to do now then. Let's put this aside here. Okay, so what we need to do now is to grab the IP address of the other Docker container that we want the RG pilot container to send the video feed to. So for that, we need to ensure that our Docker container is running. So give me a moment here. We'll go back to here and we'll go to the container tab. Once again, if you're skipping ahead from part 1, part 2, scenario 1 and 2, then go to extension, install the extension that's needed for Docker container tools and stuff like that. I'm using Cursor, so I'm using the dev container. If you're using VS Code, that's fine. Look for the equivalent one for VS Code. Go to the container tab, and then for my case, this is the Docker container I want open and started. So I'll start that up here, and there we go. Once that is started, we can now grab the IP address then. So minimize that, go here. And then what we want to do is to docker execute -i. Actually, we don't need that. Sorry. We want the Docker container name, which I called PyTorch. I'm pretty sure. Yes, there we go. PyTorch with OpenCV cat, and we want it to give all. Oh, and there we go. All the hosts that is currently connected. Okay. So the one key one that you want to know is this one here at the very bottom. This is my object detection Docker container's IP address. So we need this to be put into the Gazebo UTP host link, which I will show you soon. And then of course then you have your host and Docker internal IP address that we still need for this case. So put this aside here. Okay, I'm moving the second monitor here. Do want to note it typically is on the bottom. Okay, so it typically be the last one with random assortment of numbers, but that is the IP address you need to look for. Next we'll go back to Docker container first. Holding. Close that just to make sure I start from the start. We right click in the Gazebo one. We attach to it. I'm using cursor, of course. Using VS Code, probably called VS Code. Open folder, go to home, go to Docker user. Okay. Open that up. Okay, nice. And then we want to go to dev, go to install, go to rgpilot Gazebo, share, Gazebo models, and we know exactly this is the gimbal small 3D, the model, and then we need to change the IP address. So it wouldn't be the host.docker.internal. It would now be the container for my object detection. So we do that. So that is saved, that is done. Now we go and run the Gazebo environment here. Let's see, we're once again using the Iris runway. Let's see now. I hope I spelled this right. Okay. There we go. It's working. That's great. Now we just need to make sure what is the environment that it is running this stream from. So we'll go find the topic. We'll go to Gazebo. Tell us, ask it to find. Oh, back to UK. Yep. Yes. Grab. Tells exactly the one that is currently says streaming on it. Okay, that's the location. Fantastic. We want to grab the topic. Actual location. Okay, I found my mistake. So then now we have the video that's being streamed from Gazebo to my other Docker container. Let's open up the other Docker container then. We'll put this down for now, and then we open this up, attach to it. Actually, before we actually run this particular one, let's go to do a Python free and check the network is actually coming in. We should see receiving some sort of data coming in here. So if we do the exact same code, actually let me go backtrack one here. Okay. Backtracked it once. We don't want rgpilot, we want network. We want to change this to port 5600. We want Python free, and we want to run that. Oop, there we go, and there we go. And there we go, we see exactly where it's coming from, and it says it's coming from the IP address that we sent it. So that's fantastic. Of course, it's coming from 2, that's because it is a different Docker container like. It wouldn't be on 1 because it's the one it's currently on, so yes. So let's move on. Go back to that object detection then. We go to the inference of that. So now we know that that is coming in. I had it set up so that now it should, once it's coming in, we want it to actually give us the data. They should be able to see it. Give me a minute, this will appear in the second monitor. I'll drag it over here in a second. Oh, never mind, it's appearing here. Fantastic. And there we go. This is the object detection here. Like, not the prettiest, but it is still pretty good for me. So we will have this. Let's do something here for now then. So we don't need this. We'll go back to the Docker container that we have everything running. So let's open a new tab, and what we want to do then is to run a command from the first scenario. This is the command, and then we run it. Give me a moment. Should be done. Yeah, there we go. Fantastic. Should hopefully see a connection between the two. Kevin from editing here. I'll be explaining what has happened. Some of you might have noticed that when I closed the window for my rgpilot and Gazebo container, that I did not stop the operation of my rgpilot running from the previous scenario, meaning I could not bind to the port. It required it because it is still in use. So to fix this, I have restarted my rgpilot and Gazebo container, which properly start a fresh new session. We start the Gazebo session, yes. Fantastic. We then want to start this up. Yeah, now we're connected. Fantastic. We don't need this now. We then want to ensure that the stream is that location, and that should hopefully be the same location. Open that up. There we go. And we should still have feed coming in. So the connection is working. We'll put this here. We do need console's fine. Put this here, which will disappear soon enough, like anyway. But here, that's fine. We are getting the stream back. That's a stream happening. And now we're going to open up a mission planner. There's a lot of things happening on screen, but let's hope that you can kind of gauge what's happening over here. Like, okay, let's give it a quick mission. Wanted to zoom into the location where the quadcopter is. Take off. Go around 1, 2, 3, 4, and there. And then we land. And land. Now we run this. I mean, write it. And then we go back to data. We go here, we insert this first drop down box, we have the mission start ready, we got the flight plan been received in rgpilots, and in a Docker container, and we arm it. Then we say do mission. Do you want to start it? Yes, we do. And there we go, it started instantly, and you can see here, it's flying. There it is, it's flying away, and we can't see it no more. But we can see the actual object detection working. In terms of the frame rate, I am a bit unsure. I still need to look into it, being like it's a wee bit slow, but if I were to look in comparison to this video feed to the one in Gazebo, actually, I feel like it is similar. Yeah, it looks a wee bit similar, like maybe a bit more smoother. Slightly more smoother, like, but yeah, this would be the actual frame rate currently is. As I said, this is just a pre-trained model, like there hasn't been any fine tuning and stuff like that. I'm hoping to do that near in the future. But yes, this is it. This is the entire like 2 Docker containers communicating with each other while also communicating to Windows. But yeah, hopefully all these kind of scenarios help you get to where you want to get done, hopefully, of course. For me, it'd be completely something different, kind of for fun, but also kind of see how all the Docker works, as well as object detection, rgpilot, and how they all can interact with each other. Like, hopefully, that's my plan. Hopefully later on, but yes. This has showcased everything in terms of the camera feed and so on, object detection being processed, mission planner coordinating the mission, and yeah. So thank you for watching, and I hope this has been useful for yourself then. It certainly was for me, as going through all this, and I'm still learning all this myself. So if I've got anything wrong, or if there's something you think that could be explained better, please drop a comment and I'll try my best to answer you. But yes, let me know. And if you want to see more content like this, like and subscribe. We shall see what I plan next to learn. Who knows at the moment. But yes, thanks again, and I'll see you in the next one then. Thank you.